you guys. I'm here. I'm hoping you're having a great day. This is Friday, April 3rd, and this is, of course, a periodic table that you're familiar with in our classroom. And I am obviously in room 320 making this video for you. I'm missing you guys. I'm hoping everything's going really well for you during these strange circumstances, and looking forward to providing you with a great opportunity for distance learning, especially with regard to chemistry here in the fourth quarter. Anyway, this video is going to be a review for you. I have just sent you an email about using Harmony. Sent you to your GCA email accounts an email with the Chapter 16 assessment attached to it, and I wanted to give you a review of Chapter 16 because it's been weeks since we've talked about it, and it's of course what I would do if you were all here in class with me, is I would do a review of Chapter 16. So I'll probably, I started the video here looking at the periodic table. I am also probably going to turn this Chromebook toward the whiteboard, and I will probably do some drawings on the whiteboard. Maybe not. It all depends on how well I can do this review for your sakes. So anyway, be sure to print out the chapter test as we go through this review, because you'll be able to do well on the test if you print it out already. It was attached to the email I sent you. I love you. Sorry I'm rambling. Okay, so a blank is matter that is composed of one type of atom. So obviously that is an element. An element. Every one of these elements is composed of one type of atom. And what makes it, of course, one type of atom is the fact that it has a certain number of protons. The atomic number of plutonium right here is 78. Okay? I'm pointing at 78. There might be some glare, might be hard to see 78 there, but of course hydrogen, way up here at the upper left, has an atomic number of 1. It has 1 proton. Helium has 2 protons. We've talked about sodium quite a bit. It has 11 protons. You might be able to see there. I'm pointing at the atomic number of 11. So the way this is all set up is by atomic number. Okay? You keep adding atomic number. Uranium has 92, atomic number of 92. And that is the largest element that exists in nature at our atmospheric temperatures and pressures and conditions. Uranium is the largest element. All the rest of these elements pretty much decay, and then we come up here to those. They pretty much decay through radiation, radioactive fission. They throw off alpha particles. They split in half. They do different things. We learned a little bit about polonium. It's PO, I believe. Polonium spheres. There. Polonium 84. Polonium actually creates spheres in granite, and we learned about how because when they throw off alpha particles and even become iron, okay, an iron element, these particles fly off through the granite and create a sphere that's much larger than any single atom is, and of those alpha particles and iron atoms and things. And so we know that polonium's radioactivity is very fast, and what that is evidence for granite being produced in 3 seconds. It didn't come from molten earthen primordial soup that then slowly cooled and solidified. That's not where granite came from, because there are polonium spheres in virgin granite all over the earth. If we didn't see that movie, let me know. I think we saw a movie about that. So, element, number one. Number two, the smallest piece of an element that still retains the properties of the element is an atom. The nucleus of an atom is positively charged. Neutrons have no charge. Electrons have negative charge. Protons have positive charge. Protons are made of 3 quarks. The 6th quark is also known as the, I can't remember the name of that quark, but it's one of those quarks that they had difficulty discovering, and I think the name for that can be found in your textbook. The area around the nucleus where electrons are most likely to be found is called the Electron Cloud. Good job. The number of protons in an atom is the atomic number. The blank of an atom is the sum of the number of protons and the number of neutrons in the nucleus. And that, of course, is the atomic mass, the mass. They count protons and neutrons as having significant mass related to the atom, and electrons, of course, have negligible mass associated with the mass of the atom. So, the atomic mass of an atom is the sum of the number of protons and the number of neutrons in the nucleus. And then I think we probably talked about Avogadro's number being the atomic mass times Avogadro's number is how many grams per mole of the element. Okay, the blank of an atom is the sum of the number of protons, okay, we already talked about that. Number 12, the mass number minus the atomic number equals the number of, the mass number minus the atomic number equals the number of, well, that would be neutrons, wouldn't it? The number of neutrons. Atoms of the same element that have different numbers of neutrons are called, so they're the same atom, but they have a different number of neutrons. Those are called isotopes. Okay, in the periodic table, the elements are arranged by increasing atomic number and by changes in physical and chemical properties. The vertical columns in the periodic table are called groups. These vertical columns are called groups. More over here. Every vertical column is a different group, and those groups have names. The horizontal rows in the periodic table are called periods. This is a period. The row. That second row. The first row only has hydrogen and helium in it. Okay? Horizontal rows are called periods. Okay, make a general statement about the differences among isotopes of the same element. I think you guys are capable of doing that. So we'll see how you do. A general statement about the differences among isotopes of the same element. Make a general statement about the relationship between atomic number and the identity of an element. Make a general statement about the relationship between the atomic number and the identity of an element. Okay? That'll be something interesting to see how you guys do on that. Number 3 on these understanding concepts, make a general statement about the chemical reactivity of members of a group on the periodic table. So what's the group? The group is the column. So what is a general statement you can say about the chemical reactivity of any given group? The group of elements that are in a column on the periodic table. We talked about that quite a bit. The reason it's called a periodic table is because there's periodicity. in the elements. And so they've created this fancy table to show the periodicity. Now helium has a full outer energy level. Way up there at the top right, it has a full outer energy level, level 1. And so it is inert. It doesn't react. It doesn't give up an electron. It doesn't receive an electron. So here on the first row of on the first period of the periodic table, you have hydrogen and helium. And then on the second row, you have not only the two s orbitals of electrons for electrons to fit in, or the one s orbital with 2 electrons in it, but you also have the 6p orbitals over here as they fill up on the periodic table. We talked about that quite a bit last quarter. So I hope that's an easy thing. Making a general statement about the chemical reactivity of members of a group on the periodic table. What is true about all of this group? What is true about all of this group? What is true about all of this group? So if the same thing is true for the group, then you can make a general statement about that. Chemical reactivity. Okay? This atom has 12 electrons, a friend says. 3 are in the first energy level and 9 are in the second energy level. Okay? How would you respond? Well, we just got done talking about the first energy level, and then we started talking about the next energy level. And if it has 12 electrons, how many protons does it have? It's got 12 protons if it's got 12 electrons. So you're talking about the element magnesium here, okay? So this atom has 12 electrons, a friend says. 3 are in the first energy level and 9 are in the second energy level. Do you buy that? We're talking about magnesium. It's in the third row. What's true about where the electrons are located in versus energy level in magnesium? Okay. So we're going to continue applying concepts here. Write a multi-paragraph essay in answer to each of the following questions. Use additional sheets of paper if necessary. Number 1, reflect. Why did Mendeleev leave parts of his periodic table incomplete? Was that a weakness of the table? Explain. Holy cow, that's a really hard question. And you know what? I think you guys can do it. I think you're all right. I think we've talked about the fact that there were early periodic tables. This periodic table is not even the most up-to-date periodic table that I'm showing you here on the wall. This is an old periodic table. Okay, so the reality is then that is this periodic table weak? Is it a weakness? Or the fact that it's incomplete? Does that matter? Can you still use it today to answer most questions about chemistry? Yeah, the only thing you don't know is what we've called element number 10 with atomic number 109. We have UNE here. Unknown, maybe unknownium or something like that. You know what I'm saying? So anyway, they probably updated the name of that, and maybe even they've added a few more here after atomic number 109. Scientists are crazy. They love bombarding smaller elements with alpha particles to make them to be bigger elements. Oh, it's so much fun. Think about that. I'm bombarding these atoms with alpha particles and making the nucleus of the atoms larger. Yay! All right, so why did Mendeleev leave parts of his periodic table incomplete? Was that a weakness of the table? Explain. All right, so number 2. The mass of the electrons is so small that they don't make a difference to the atom. That's a quote. Someone says, how would you respond? So I would expect you guys to figure out what the mass of an electron is compared to the mass of a neutron or a proton. You might look that up. What is the mass of a neutron? What is the mass of a proton? And what is the mass of an electron? And notice for yourself why it's a good assumption to assume that electrons don't weigh anything or don't matter with regard to mass, because they're that much lighter. I want to know how many multiples of 10 is the electron lighter than the proton and the neutron. Okay? So that ought to help you to complete your Chapter 16 assessment. And I'll be seeing you again next week to talk about Chapter 17, where we'll get further along with our understanding of chemistry. I love you guys. I hope you're having a great week. Hope you have a great weekend, and I'll see you next week. Good Friday and Easter are coming a week from now. Be sure to thank God for all that you have, your loving parents, your loving science teacher, your don't thank God for me too much, but do pray for me. I need your prayers as much as anybody. I am weak. I am imperfect, and let's end in prayer. Lord Jesus, we know that you are amazing. You have our back in every way. And if we would just treat ourselves and others as the unfathomably precious people that we are, everything would be great. We wouldn't be able to complain about anything because we would realize that no other person is our enemy, and we would enjoy all of our relationships much more so than we currently do, and we would enjoy you much more than we do. We would have even greater appreciation for you, because think about it, if everybody was treating everybody else as though they were unfathomably precious, as they are, and to do otherwise, to not treat someone as unfathomably precious, actually is to mistreat them. So we don't want to do that. Help us, Lord, to see you and see others as you see them, with true love. In your mighty name, Jesus, amen. Hey, I love you guys, and I do hope that you're having a great day. It sure is pretty outside, and I'm looking forward to getting there myself. So you know that I'm missing you, and I'm caring about you a lot, and I really hope you do well on this Chapter 16 assessment. I sent it to you via email. God bless.